Welcome to the Explainer. Today we're diving into Puppet, a tool that absolutely changed the game for managing modern infrastructure. We're going to talk about how it brings order to the chaos of our digital worlds.
So, here's what we're going to cover. First, we'll look at the big, messy problem that even created the need for a tool like Puppet. Then, we'll see how Puppet acts like a blueprint for a solution, get into the nitty-gritty of how it works, check out what the code looks like, and wrap up by seeing where it fits in the whole tech ecosystem.
All right, so to really get why Puppet is such a big deal, we have to go back to the beginning. We need to understand the problem it was built to solve. And honestly, it's a problem of pure chaos. I want you to just imagine for a second that you're in charge of a whole fleet of servers. Not 10, not 20, we're talking hundreds, maybe thousands. Now imagine trying to log into each one manually to install software, apply a security patch, or just change a configuration file. It's not just slow, it's a recipe for disaster. There's just no way that scales.
And that brings us to this monster of a problem. Over time, little things change. One server gets a quick manual fix, another has a slightly different library version. This is what we call configuration drift, and it's like a silent killer for IT systems. That, plus simple human mistakes, is exactly how major security breaches and huge outages happen. So how do you stop it?
So how do you fight back against all that chaos? Well, Puppet's answer is actually really elegant. It says, stop treating your servers like pets you have to care for by hand. Instead, treat your infrastructure just like you treat your software, by defining it with code.
And that big idea is called infrastructure as code, or ISC for short. What it really means is that you write down exactly how you want everything to be, your servers, your networks, all of it, in simple text files. That code then becomes the one and only source of truth. It's the master blueprint that makes your entire setup something you can repeat, test, and automate.
Now, this is really the secret sauce of Puppet. It uses what's called a declarative model. You see, you don't write a script telling it how to do something step by step. Instead, you just declare what you want the final result to be. You just say, hey, I need the Apache web server installed, and I need it running. That's it. It's Puppet's job to figure out all the commands to make that happen, no matter what state the server is in to begin with. And this philosophy really gets to the heart of what Puppet is all about. It's not just about automating the boring stuff. It's about creating a system that continuously enforces a consistent, secure, and correct state across every single machine you manage.
Okay, so this all sounds great in theory, but how does Puppet actually pull it off? Let's pop the hood and take a look at the architecture and the workflow that brings this all to life. The setup is basically a classic client-server model. You've got the Puppet master, which is kind of the brains of the whole operation. Then, on every single machine you want to manage, we call those nodes, you install a piece of software called the Puppet agent. That agent uses a little tool called Factor to learn things, or facts, about itself, like its operating system or IP address. It sends those facts to the master, which then builds a personalized to-do list called a catalog, just for that specific node.
And the really cool part is that this whole process runs in a continuous loop. By default, about every 30 minutes, every agent phones home to the master. It sends its facts, gets its custom catalog, and then makes sure it matches that catalog perfectly. And then it reports back on what it did. This means that if someone goes and makes a manual change, Puppet will just automatically fix it on the next run. It's constantly fighting that configuration drift for you.
All right, we've got the architecture down, so now let's get to the fun part and actually look at what this infrastructure as code really looks like when you're writing it in Puppet.
So, this is a simple Puppet file, which we call a manifest. And honestly, even if you've never seen this before, you can probably figure out exactly what it's doing, right? The first bit makes sure a package called HTTPD is installed. The second one makes sure the HTTPD service is up and running. And that third one creates a simple little web page file. It's super readable, it's declarative, it's just really clear and powerful.
So how do you scale this up? Well, it's all about organization. You start with these basic building blocks called resources, things like a package, a service, or a file. Then, you group related resources together into classes. So you might have an Apache class that handles both the package and the service. And then you bundle those classes into shareable, reusable modules. A single module might manage an entire web server stack, and you can use it over and over again. Now, this is a super important concept in Puppet. It's called idempotency. All it really means is that if you run your code on a server that's already configured correctly, Puppet is smart enough to not do anything. It just checks, sees everything is good, and moves on. This is what makes the automation so safe and predictable. You can just run your code over and over, and you never have to worry about accidentally breaking something.
Okay, let's zoom out a bit. Puppet doesn't live on an island by itself. It's a huge part of the modern DevOps world, so let's see how it fits into that bigger picture.
Puppet is a really key player all across the automation pipeline. Let's say a new server gets spun up in AWS or Azure. Puppet can be there to automatically configure it from scratch. When you're pushing new application code through a CI/CD pipeline, Puppet can handle the infrastructure changes right alongside it. And it's an absolute beast for continuous compliance, making sure your systems are always locked down and meeting security standards.
Now, of course, you've probably heard of other tools like Ansible or Chef, and they all solve similar problems but in different ways. One of the biggest differences is the mode. Puppet uses a pull model where each agent checks in with the master to get its instructions. Other tools like Ansible often use a push model where a central server sends commands out. Puppet's declarative, agent-based pull model is really good for managing huge, complex environments over the long haul, where constantly enforcing that perfect state is your #1 goal.
So at the end of the day, what tools like Puppet let you do is turn your entire complex infrastructure into simple, readable code. It brings stability and speed to what can be a really chaotic world. It lets you write the story of what your infrastructure should be, and then it works tirelessly to make sure reality always matches that story. So the real question is, what story is your infrastructure telling?